Today we're going to be looking at parallel and perpendicular lines and how to write the equations of those lines. We're really just building upon exactly what we did yesterday. Okay, so the first thing is to just know what these two words mean. So hopefully we know that parallel lines are lines that are equidistant from each other, right? They never intersect. Parallel lines always have the same slope. And hopefully that makes sense because they have the same steepness, right? If they can't ever touch, they have to be just as steep as each other. Okay, so if I have a line that has a slope of 4, a line that is parallel to it will also have a slope of 4. And this sort of big old long 11 is how we represent parallel. Okay, so we would say 4 is parallel to 4. Right? A slope of 6 is parallel to a slope of 6. Okay, perpendicular lines are lines that meet at a 90-degree angle. That top line was not straight at all, but we'll pretend. Okay, where they sort of meet at a T. Now, they don't have to be directly up and down, right? If they're sort of angled like this, they still meet at 90-degree angles. So we'll see the T somewhere. It just might be sideways. And perpendicular lines have opposite reciprocal slopes. Where hopefully we know that opposite means that it's the opposite sign. So a positive becomes a negative becomes a positive. And reciprocal tells us to flip-flop the fraction over. So if I have a slope of -3/4, okay, and upside down T is how we represent perpendicular. We would want to take the opposite sign. So that was a -3/4, so we would make it a +3/4, and then we'll flip the fraction over. So -3/4 is perpendicular to a +4/3. If we have something like a slope of 2, it's a little bit tricky. It's easy to take the opposite and to make it -2, but we also need to flip-flop it, right? So this is really 2/1. So when we flip-flop that, we would get a -1/2. So we're going to be writing equations of lines today that are parallel or perpendicular to each other. So let's say I want to write the equation of a line that is parallel to y equals 3x minus 7 that passes through the point -2, -5. Okay, so parallel to y equals 3x minus 7 and passes through -2, -5. Okay, so what this is asking us to do, if I were to graph y equals 3x minus 7, right, this line right here, it wants me to create a line that is parallel to it that passes through the point -2, -5. Now, you absolutely could continue graphing on here and then write the equation from the graph. Just doesn't tend to be the perfect solution because if we don't get a nice, neat y-intercept, we end up having to do point slope form anyways. So I'm just going to start there because it will work all the time. So parallel means I need the same slope as the original line. So my slope on this first line was 3, so I know I'm going to need to keep that slope the same, right? That's what parallel tells me to do. They have the same slope. And I'm going to need it to pass through the point -2, -5. So now I have a point and a slope, so I can plug it into point slope form. So remember, point slope form says y minus y sub 1 equals m times x minus x sub 1. Okay, so I'm going to say y minus my y coordinate is -5 equals m, which is 3, times x minus my x coordinate, which is -2. And just like yesterday, right, my two negatives become a positive. We've been doing that for several days now. And I'm going to solve this for y. Okay, I'm going to do that because I always solve for y. And then I'll undo adding 5 by subtracting 5. Okay, and so I get y equals 3x plus 1 is going to be parallel. We know that because they have the same slope, and it's going to pass through the point -2, -5. And if I were to graph that over here, right, I'd be at 1, up 3/1, but I'm going to go down this way just to show, right, it does still end up going through that point, and it is parallel. So it does exactly what we needed it to do. Okay, so let's look at another one. Okay, let's say we want to write the equation of a line that is perpendicular it's a long word to write down, perpendicular to y minus 5 equals 2/3 times x minus 7. Okay, so if I do that, I need to find my, I also need a point for it to pass through. I didn't finish writing down the problem. I want it to pass through the point, I'm just gonna shorthand this over here, 1, 9. So I want it to be perpendicular to this and pass through the point 1, 9. Okay, so to write the equation of a line, I know I'm gonna need a slope. So my slope in the original equation was 2, 3. And you might say, Mrs. McKinney, what's happening with all of this other stuff? Nothing, right? It's not important for me to write the equation of the new line. I just need the slope. Okay, and I want to be perpendicular to 2/3. So I'm going to take the opposite. So I'm going to make it negative and the reciprocal. So I get -3/2. So I know I want a slope of -3/2, and I want it to pass through the point 1, 9. Again, I have a point and a slope, so I'm going to plug into point slope form. So y minus 9 equals -3/2 times x minus 1. I'm going to solve, because I always solve. So I'll get a -3/2x, a -3/2 times a -1 is a +3/2. I'll undo subtracting 9 by adding 9. Feel free to use a calculator if you want. It's exactly why we practice doing those fractions at the start of the trimester. Okay, so a 3/2 plus a 9 will give us a 10 1/2. You could write that as a 10.5. You could write it as a 21/2, whatever. Okay, either way, we get a final answer of y equals -3/2 x plus 10 1/2. Now, there is one sort of tricky situation, and that is what happens if we want to write the equation of a line that's perpendicular to x equals 5 that passes through the point -4, 1. Okay, so here we don't really see a slope. So what we instead need to know is that an x equals line is a vertical line, and a vertical line always has undefined slope. Okay, so then what would be perpendicular to undefined slope? Well, perpendicular to a vertical line would be a horizontal line, and a horizontal line has a slope of 0. Okay, so I need a slope of 0. And I need to pass through the point -4, 1. So y minus 1 equals 0 times x minus -4. Doesn't really matter if I turn this into a positive, because when I distribute 0 times anything, it just becomes 0. So I'll get y equals 1. Now, you could have also recognized that this was a slope of 0, and a slope of 0 means a horizontal line, and a horizontal line is always a y equals line, and so you could have got y equals 1 from there as well.